Okay, just for the recording, I forgot to start the recording. But okay, this is the last thing we're looking at in section 1.7. Here are the steps we're going to do. This is in the textbook. Let's do one. So step 1 says get everything on the left-hand side. So my first step is to subtract 4 from both sides. I'm going to write it 4 over 1 for a reason that will become obvious here in a second. And 0 on the right. So far I've got everything on the left-hand side and 0 on the right. But step 1 is saying, no, I want just one fraction on the left-hand side. So what's my common denominator here? You're right. Thank you, sir. So now my question is, what do I have to multiply that 1 under the 4 by to make it look like x minus 3? X minus 3? So I start putting all of this together here. So I've got 6 minus 4 times x minus 3. Here's my numerator over my common denominator. All that is greater than or equal to 0. I distribute that negative 4, so I've got 6 minus 4x plus 12 over x minus 3 greater than or equal to 0. I've got minus 4x plus 18 over x minus 3 greater than or equal to 0. And stop right there for a second. Now I'm done with step 1. I've got just one fraction on the left. I've got 0 on the right. And whatever inequality symbol there is. Step 1. Step 2 says, take the numerator, solve it as though it were an equation. So I'm going to say minus 4x plus 18 equals 0. And so when I divide both sides by negative 4, I get x equals 4.5. There's one of our critical values. Now see, yesterday with those quadratic ones, what do? We solved the quadratic, we got down to the 0 factor property, and then we figured out our critical values. Here, we're taking the numerator and denominator and solving them for 0. All right, my next one is take the denominator, x minus 3. I'm getting that. That's our other critical value. Now, sometimes you'll have one critical value. Sometimes you'll have 2. Sometimes you'll have 3. All right, we're done with step 2, except for chopping the number line up. So I've got this, I've got 3. Now, can it equal 3? At first glance, you say, yeah, because, why? Because that symbol is greater than or equal to right there. But let me ask again. Upon further inspection, can it equal 3? No. Because if it equaled 3, that denominator x minus 3 would be 0. So I've got to write myself a note. X cannot be 3. We good now? So it can't be 3. Can it be 4.5? Sure. Because that greater than or equal to. So I'm going to put my 3 as an open dot. And my 4.5 has a closed dot. Now we just have to work out which of those sections of the number line will work. So here I've got 3, I've got 4.5, and we start testing. So I need a number smaller than 3. 0 is good. So I've got 6, 0 minus 3, is that greater than or equal to 4? That's what I'm testing. So I've got 6 over negative 3. Now I've got a negative number on the left-hand side, negative 2 as a matter of fact. That one doesn't work. So I know that's not good. Then I need a number between, slow me down if I'm going too fast. I need a number between 3 and 4.5. All right? So I say 6 divided by 4 minus 3. Is that greater than or equal to 4? I've got 6 divided by 1 greater than or equal to 4. Yeah. And then I'm going to do a number bigger than 4.5. That'll work. So I've got 6 divided by 5 minus 3. 6 divided by 2. No, I got 3 on the left and 4 on the right, so that one doesn't work. So we're talking about this area right in here on the number line. So what's the smallest it can be? Now we're back to like we did yesterday. The smallest it can be is 3. Can it reach 3? Nope, can't. Open dot. Of all the numbers on the number line, 3 we knew right up front it couldn't be. Turns out it can't be 3 or anything less than that. What's the biggest it can be? 4.5. Can it reach that one? Yes, I'll put a bracket. There's our answer. How do I know the difference between this rational kind and the quadratic kind?
There's an x squared.
Okay, there's an x squared in the quadratic. And what does this one have? What's its distinguishing feature? Yeah, fraction. That's why it's rational. You can make a fraction out of it. So you're going to have to get to where you realize, what am I dealing with here? What kind of problem am I trying to solve? Because on a test, they're going to all be mixed in together. It's not going to be a whole lot of any one thing because we're covering a chapter here. All right, let's do another one. Okay, step 1, move everything to the left-hand side. So I've got minus 4. I put 4 over 1, less than 0. All right, my common denominator is 2x minus 3 times 1, which is just 2x minus 3. And the question comes up, what do I have to multiply that 1 below the 4 by to get it to look like 2x minus 3? Uh-huh. I'm still working on step 1. So I've got 3x plus 1 minus 4 times 2x minus 3. All of that is over my common denominator. All that's less than 0. I start distributing things and combining like terms. So I've got 3x plus 1 minus 8x plus 12. 2x minus 3. Got minus 5x. 13. Now I'm through with step 1. I've got one fraction on the left. I've got 0 on the right. Step 2. Bless you. Take the numerator and solve it as an equation. So negative 5x plus 13 equals 0. So negative 5x equals negative 13. X equals 13/5. One critical value. 2x minus 3 equals 0. There's another critical value. What haven't we checked yet? Are there any values x can't be? Just right up front. Well, I'll take the denominator and I set it to 0 and see what value of x would give me a 0 here. What value of x would give me a 0 there? 3/2. You're right. The exact thing we got here as one of our critical values. So I know that x can't be 3/2. Stop right there. Does that make sense? Always check. Is there something I know immediately that it can't be? Yeah, 3/2. All right, that's no big deal. So I get my number line. And I've got 3/2, open dot. And I've got 13/5. Can it be equal to 13/5? Peyton?
No.
Good definite answer. How come?
Because it's not less than or equal to, it's just less than.
Good answer. Yeah, there's not an equal sign under that less than. It's just saying less than. So I know it can't equal 13/5 either. So I'm going to put an open dot there. Okay, look at it a minute, make sure that makes sense.
Isn't 3/2 the larger number?
Is it? 13/5 is what? 2.6. 3/2 is 1.5. Glad you said something anyway, because that's a kind of a critical point. So I've got, not that, I want what? Another page. There we go. So number line wise, I've got 3/2, 13/5. Okay, we're down to step 3. I need numbers smaller than 3/2. 1 or 0, either one. I'd go with 0, but because it makes it so easy to see. So I've got 3 times 0 plus 1 over 2 times 0 minus 3. Is that less than 4? So this cancels. I mean, not cancels, but 3 times 0 is 0. 2 times 0 is 0. So on the left-hand side, I've got minus a third. Is that less than 4? Yeah. That worked. I need a number between 3/2 and 13/5. 2 will work. Thank y'all. So I've got 3 times 2 plus 1. Just plugging it back into my original inequality up there. 2 times 2 minus 3. Is that less than 4? So I've got 6, 7 on top. I've got 4 take away 3 on the bottom. So 1 is 7 less than 4. Nope. So that interval doesn't work. Then I need a number bigger than 13/5. 13/5 is 2.6. So 3. All right, so I've got 3 times 3 plus 1. 2 times 3 minus 3, less than 4. So I've got 10. 6 take away 3 is 3. So 10/3 is 3 1/3. Yeah, that's less than 4. Got it kind of mapped out here. So what's the smallest that x can be? Thank you. Negative infinity. Can't reach it, we put a parentheses. And by the way, when you're doing the homework, there's a world of difference between that parentheses and a bracket. You can work it all right, and if we'd put a bracket there, the computer grading your homework would say, nope, not right. And so really I'm talking about from here out and from here out. So then what's the biggest that piece could be?
3/2.
Good. Can't reach it. And then union, the other side. On the other side, the smallest it can be is 13/5, but we can't reach it. Up to positive infinity, which we can't reach. So there's our answer right there. 2 pieces. Like I said, this is very similar to what we did yesterday. But I wanted just a day of just this kind. I've only got 4 examples. Let's look at another one. Unless somebody has a question. Okay. Avery, what's the first step?
Everything on the left.
Okay, so I've got plus, and I'll just do 1 over 1. Less than 0. Okay, thank you. A common denominator is what, Riker?
X plus 2.
Uh-huh. Thank you. So that means I need to multiply this denominator by x plus 2 and this numerator by x plus 2. All right, I'll start clearing some of the smoke out. I'm not done with step 1 yet. So I've got 1 minus x plus, when I distribute the 1 here, I've got x plus 2, common denominator, less than 0. Okay, now this one's a little bit different. My negative x and positive x cancel each other out, which leaves me 3 over x plus 2, less than 0. This one's different. There's no x's in my numerator. I can't say set the numerator to 0 because then I'd be saying, well, 3 equals 0. No, that doesn't make any sense. So I just go with the denominator. So step 2 here is going to say, all right, just work with the denominator. So x plus 2 equals 0. X equals minus 2. And I'll bring up the age-old question, is there anything just right off the bat that x cannot be? Thank you, negative 2. So x cannot be negative 2. How many critical points do we have? On the other two examples, we had 2. I'm just seeing 1 here. Okay, so we do our number line. And I just got negative 2. And it has to be an open dot because x can't be negative 2. Now I'm going to test on either side of it. So what's a number smaller than negative 2? Negative 5. Okay. So I'm going to plug that in. So I've got 1 minus a minus 5. I'm going back to my original inequality. Minus 5 plus 2. Is that less than negative 1? So on top I've got 6. On the bottom I've got minus 3. On the left I've got negative 2. Is that less than negative 1? Yeah. That's how it works. And then I need a value bigger than negative 2.
0.
Yeah, always go with a 0 if you can. So I've got 1 minus 0. I've got 0 plus 2. Is that less than negative 1? Well, on top I've got 1. On the bottom I've got 2. Nope. So this side doesn't work. So my interval ends up being just this out here. So the smallest it can be is negative infinity. The largest it can be is negative 2, but it can't reach it. So there's our answer. One more. This one's got a little different twist to it. So first step is saying get everything on the left. So I'm going to add 4 over x to both sides. And I got greater than 0 here. Oh man. Now see, don't get lulled into thinking the common denominator is always just one. If you look back at the other 3 that we've done, the common denominator was always just whatever fraction started off over there. But here, what's the common denominator going to be?
Be x times 2x minus 1.
Good. There's our common denominator. Is there anything x cannot be? Yep, 1 over 2. And 0, right? Because if x were 0, that fraction that starts off on the right-hand side would have a 0 denominator. This one. So, two values that x we know cannot be. All right, so now then, I need to get these fixed. Let me just move this whole thing over. Don't want to do that. Okay, scoot that over a little bit. The denominator, 2x minus 1, what do I need to multiply by, bless you, to make that our common denominator? Thanks. So x. And the 4 over the x in the second term there, I need to multiply by 2x minus 1. It's not that it's hard, it's just there's a lot of little details you got to keep up with. Okay, so I've got 3x plus 4 times 2x minus 1. I'm just going to leave this. I'm not going to multiply this out on the bottom here. So on top I've got 3x plus 8x minus 4. Yep. X times 2x minus 1. All that's greater than 0. So finally over here, to finish up step 1, I've got 11x minus 4 over this. Got one fraction on the left and 0 on the right. Let's get some critical values here. I'll take the numerator, step 2. 11x minus 4, not over anything, equals 0. 11x equals 4, x equals 4/11. Now that's not one of our values that x cannot be. So there's a critical value. I take my denominator now and I've got this. X times 2x minus 1 equals 0. What am I looking at there? That's a 0 factor property, right? I got two factors, I multiply them together, I get 0. So another critical value is going to be, I set each one of them to 0. So I'll just go x equals 0. There's a critical value. Notice though it can't be 0. And I've got 2x minus 1 equals 0. Half. Notice it can't be a half. So it could be 4/11. No, it couldn't, because why? That's right. Right back up here, this just says greater than. There's no equal sign there. So it can't really be any of these critical values. So we're talking about numbers on either side of them. Okay, let's get some of this stuff copied over. There's that. Our number line, let's go back here and see. I've got 4/11, I've got 0, I've got a half. 4/11 is a little bit less than a half. So it's going to go what on the number line? 0, 4/11, a half. Can't be 0. Open dot. It can't be 4/11. Can't be a half. Y'all, we got 3 critical points. Look how many chunks it divides the number line into. 4. So I need a value less than 0. How much? -1. Okay. So I'm going to test over here. I'm going to say 3 divided by 2 times -1 minus 1. Is that greater than -4 divided by -1? So on the left I've got 3. I've got -2, -3. Is -1 greater than 4? No. So I know that part's gone. All right. So then I need a number between 0 and 4/11. Wow. If it was 4/12 right here, that'd be a third. So this is a little bit bigger than a third. So we could try a third or a fourth. What do y'all want to do? Okay, so let's try a fourth. So I've got 3 over 2 times 1/4 minus 1. Is that greater than -4 divided by a fourth? On the right, left-hand side, I've got 3. 2 times 1/4 is a half. A half take away 1 is -1/2. On the right-hand side, I've got -16. How come? Because we keep, change, flip. Right, so I'm getting -16. 3 divided by -1/2 is what? -6? Is this true? Yeah. Ding. I would not give you one with 3 critical points on a test. That's just madness on a test. But I want you to see, well, we could have more than 2 critical points. So we could have 1, we could have 2, we could have more than 2, depending on how complex those fractions get. So now I need a value between 4/11 and a half. Yeah, that's kind of... Five elevenths, okay. Weird little numbers, huh? So I've got 3, 2 times 5/11. Oh, yeah, got to put my -1 down there. Is that greater than -4 divided by 5/11? So over here I've got 3, I've got 10/11. Didn't write it right. Said it, but didn't write. So 10/11 minus 1. Is that greater than? So what's -4 divided by 5/11? -44 fifths, which is what, about -8.8. On this side, I've got 3. What's 10/11 take away 1? Now 1 is 11/11.
-1.
Yeah, thank you. Yikes. So 3 divided by negative 1/11 is negative 33. So is negative 33 greater than negative 8.8? No. Double check my math. So we've got 10/11 minus 1. 11. Y'all getting the same thing I am? I'm not seeing that I made a mistake. That doesn't mean I didn't make one. Well, in that case, that's not true. 1 to go. Thank goodness. Finally, something we can do without exploding our minds. I need something bigger than a half.
1.
Thanks. Or 0, right? If you got the option for a 0, take it, because it usually makes things easier. So I've got 3 divided by 2 times 0.
How is 0 bigger than 0.5?
Well, it's not. What are y'all saying? 0's not bigger than that. So 1, just like I wanted to do in the first place. All right, so we got 3 divided by 2 times 1 minus 1. That's a times there. Is that greater than? I was just hopeful. 1. So I've got 3. 2 take away 1 is 1. Is that greater than negative 4? Yeah. Okay. I'm going to shrink some of this down so we can have room for our answer. Okay, so what are we talking about here? We're talking about this and this. So, what's the smallest my left-hand chunk can be? 0. Can't reach it. The biggest it can be is 4/11. Can't reach it. Union. Smallest, the right-hand chunk can be is 1/2. And the biggest it can be is infinity. Can't reach it. There's our answer. Like I said, I would not give you one like that on a test.